Hi everybody, it's Mrs. Harbin. We're going to differentiate between polar and nonpolar bonds, and now we're going to talk about molecules, right? And then we're looking at the two factors of bond type and shape. We're going to give structural formulas of a molecule and determine if it's polar or nonpolar. So read page 237 to 240 and look at the pictures. Yes, we will look at the pictures. All right, so polarity means ended. Polar bonds mean we're looking at part of a molecule, and we look at the polarity, okay? So say that carbon has an electronegativity of 2.5 and fluorine has an electronegativity of 4.0. This is a polar bond, so we have kind of a negative side, kind of a positive side. We already know that. How do you figure it out? You subtract the electronegativity, get 1.5. 1.5 means polar, okay? So we use positive, partial negative, or use the arrow, which means negative and positive. Polar molecules, though, aren't just the bonds. They're the whole molecule. So here's a polar bond right here because oxygen's 3.5 and hydrogen's 2.1. What's the diff? 1.4. So this is a polar bond. So we have a kind of negative side and a positive side on that bond. There's another polar bond in the molecule. And so if you look at this whole molecule and you circle the different the positives and negatives, well, we have all the negative up here, so this molecule overall is polar. Okay, so in order to see if a whole molecule is polar, you have to look at the bonds and you have to look at the whole. All right, so this one has polar bonds and it's a polar molecule. You have to look to see if that's true or not. So, oh look, it's some molecules, right? This is a nonpolar bond because this is a 2.1 and a 2.5. So it's 0.4. So this is nonpolar, so we can't draw any arrows on that. Here's a 2.5 and a 3.5. So this polar bond, the CO bond, is polar, and it's polar in that direction. Look, a CO bond that's polar in that direction. So we got kind of negative over here and positive right here. And then over here, an OH bond, whoops, wrong direction, is also polar, so kind of positive, kind of negative. So this molecule, because of its shape, has a negative side over here, a little bit negative side over there. They don't cancel out, so it's a polar molecule because the polar bonds don't cancel. Okay, look, it's HCl. HCl is a one-bond molecule, and the chlorine is hogging the electrons. So this is a polar molecule because over here is negative and over here is positive. Oh, look, it's C2H6. Okay. This bond is not polar, it's between two carbons. That bond is not polar because it's between two carbons, so I can't draw any arrows. No arrows. Why? Because there's no polar bonds. What does no arrows mean? That means that this molecule can't be polar overall because there's no polar bonds in it. So here, polar molecule. This is going to be a non-polar molecule because there are no dipole arrows in it. Let's look at some more. We're going to look to see if a molecule is polar. A polar molecule exists if there's dipole arrows that are separated from each other. So this is the negative side. If you circle one charge, all right, and that one charge is in a different place than the other charge, all right, and so that overall, here's a negative side of the molecule and here's a positive side, that's polar molecule. All right. All of these on this side are polar molecules. Oh, look at that. Polar molecule. Who spelled it like that? Oh, okay. Look at this molecule. Here's one polar bond, and one polar bond only has two sides. Okay, so you got a negative side and a positive side. So this is a polar molecule. And then the HCl we looked at has one polar bond, and that's a polar molecule. So how could a molecule ever be nonpolar? Well, this has a polar bond between C and O, and the direction of the dipole arrow goes out. But look, there's another polar bond, and the direction of the dipole arrow goes out. So if we circle the negatives, all right, it's this side and this side both are negative, so there's no opposite sides to the molecule. This side's negative and that side's negative, so this is a nonpolar molecule. Does it have polar bonds? It sure does. Right? But those polar bonds cancel out. Look, it's another molecule with 4 dipole arrows. And then if we circle the negative, it's all around the whole molecule, so we don't have opposite sides. All right, over here we had opposite side on this side of the molecule and that side. Here we had opposite sides. Here we have opposite sides. There's no opposite sides No opposite sides means nonpolar molecule. Right? So, is a molecule polar? The molecule is polar if there's one dipole arrow. Only it's got to be polar because there's nothing to cancel that out. Um, or dipole arrows point to the top, point on the top or bottom. Alright, well let's look at what I mean. Look, there's only one dipole arrow, so it has to be a polar molecule. This one, there's 1, 2, 3 dipole arrows, but it points to the top of the molecule away from the bottom of the molecule. If I circle the negative, it's only at the top of the molecule, so that means the bottom is positive. That's polar. Non-polar. Okay, so if all 4 of these arrows point out and we circle the negatives, right, there's no opposite charges on the outside. If all 3 of these point out and we circle the negatives, and then all 3 of them point out, so there's no opposite sides. Right? This one, there's no opposite sides because it's the same on the outside. In this one, there's no opposite sides. So the molecule, in order for a molecule to be polar, there has to be polar bonds that don't cancel out. In order for a molecule to be nonpolar, it either has nonpolar bonds or the polar bonds cancel out. Okay. Now, what's this going to mean about molecules in general? Polar molecules are going to love water because we saw water is polar. Water is polar overall. It's got opposite sides to the molecule. So polar things stick with polar things. Non-polar things don't. There's no arrow in this molecule because the electronegativity is constant or the same between the 2 atoms. This one, there's no polarity either. So polar molecules have water. So, write this down. Molecular polarity. Polar molecules need polar bonds. That's a must. Okay? And they need a shape. So bonds and shape. A shape that doesn't cancel polarity. Uneven overall charge in the molecule is what we're looking for polar. Nonpolar molecules either have no polar bonds, okay, so no polar bonds means nonpolar molecule, or they do have polar bonds, but those polar bonds even out the distribution of charge in the molecule. Okay, so here's the main idea. Polarity of bonds doesn't cancel, then you are polar. Polarity of the bonds cancels, you're nonpolar. No bond polarity, nonpolar. So we're talking the shape of the molecule and the shape of the molecule and the bonds. Shape and bonds decide if the molecule is polar. Okay, hey, just an aside. 7 diatomic elements. So here's a word for you, and you're saying to yourself, that's not a word. Well, it really isn't a word, but we're making a word out of 7 elements that whenever they're by themselves, they're never by themselves. So what does that mean? That means if you walk up to nitrogen in nature, you won't find N, you'll find N2. About oxygen, you won't find O, you'll find O2. About fluorine, you won't find F, you'll find F2. All right? So 7 elements on the periodic table exist as diatomic. All right, so please look at the book. Here's a question to answer. All right, and if you look at figure 8.4, page 239, you should be able to answer it. Look at this one. What happens if you put a nonpolar molecule in an electric field? What would happen? Okay, so answer those questions. Make sure you understand these 3 bullet points, and you're all